Hi, welcome, Godspeed. This channel is against the Big Bang. My previous two videos, I will connecting my video with Brian Schmidt, the Lord Nobel Prize winner, that he said that the universe is accelerating. Not only that it is getting large, but accelerating large. So now I want to I want to tell you in the beginning of this video that you cannot calculate the mass of the star through its light. And for this I brought to you here this, in Romanian we say this candela. Okay, if I bring it closer for you to see, let me tell you what I have just told you. If you take the light and you have a rate of consumption, you cannot suppose that this the container will burn. You understand? So you cannot calculate the mass, and you will not see the container. You will not see the container. Through light you cannot discover any mass of any star, if you understand. I'm telling you again this. This is an electrical way of producing light. You cannot know the mass of this. If I am going to hit this, you will not know even the volume. You see? And you will not know, even if you know the rate of the luminosity, constant luminosity waves. You will not know. And if you presuppose that the entire body will burn or convert in energy light, you will be wrong, because you know that it has a battery, and when the battery is consumed, the object is still. Okay, so they are lying. They cannot calculate the mass of the stars through light. You understand? You cannot calculate the mass only through light. They are lying, pure lies. So everything about physics, okay, the physics in 13 minutes. I made a video like this already, okay? So in my previous video you connect and you understand physics, and okay, Einstein wondered what happened if you travel at the speed of light, okay? And if you connect with my previous video, Galileo said that let's say like this: the inertia principle is more important than you think. It's more important than you think. It is a law in physics. An object will conserve the properties before, if you want to put it like this. So I explain to you physics, but this is a more important principle than you believe. The body will conserve not only the movement, rectilinear, uniform, the properties. If some other body will not intervene to change that properties, okay? This is the inertial principle. Is made only if the inertial principle is made only on velocity. On Earth you cannot observe this. If you will throw this rock, you will observe that it is consuming the momentum of movement and will fall down to the earth. So how come is true the first principle of inertia? How it is true? In the void spaces made, okay? They were not stupid. Galileo observed the moons of Jupiter. They were knowing the solar system. They are already supposing that there is a void or something. In what medium? You can ask the Jupiter with the satellites rotate. In what medium? Okay? And when they made the equations, they will not presupposing any medium, okay? So they consider only mass, forces, energy, and things that I've told you in my previous video. So now, for a short recap, these two bodies, Galileo said, this is the second law, inertia, and this is the second law, important law. This body, I will reach what Einstein said, how it will be to travel to the speed of light. This is Einstein was asking. So these two bodies fall in the same time. I've told you in my previous video. The rate of acceleration is 10 meters per second squared. And I've told you, you must understand the difference between speed, normal speed, and accelerated speed. What I have not told you in my previous video. And then Newton said it is not fair. Maybe this is going to be a bigger video. Oh. So then Newton said it is not fair why this body will fall in the same time with the same rate. And he was the first that it will give the law force equal mass of acceleration, because something must have different its object. So when it will charge a force with acceleration m, the mass of the object multiplied by 9.8 meter per second squared, and you find the force that this object will hit the table, but the acceleration is the same. So, but now I previously asked what Einstein asked, where the charge is in the object inside. Where is it? Where is it charging? The force is the force of the impact. The acceleration charge the object in pure space. Or multiply mass to hit the table with the force. This, as Einstein asked, it is more important than you think, okay? And it is acceleration, meter per second square. Now, anti-gravity. Why this is false? I've told you, gravity does not pull. It's meter per second squared. The other guys made energy, the mechanical movement. There is some quantity of energy that gives a quantity of movement, and the terms is energy, not electrical energy, okay? Energy of movement. Kinetic means to move, kinetic energy of movement. If you understand, if you put not the table here but here, it is not to be fair that here will hit with the same force, F. You understand? So if you interrupt the movement here, it will be another force of hitting. So the force of hitting will decrease with distance like this. The force, not the gravity, the force of hitting. If the body will accelerate to the ground, it will gain more force of hitting. You understand? But I've told you in my previous video, this is not enough. There is a kinetic energy, rectilinear. I throw this body like this way, perpendicular, parallel with Earth. There is always a vector, and I've told you it's here in the rock. Seems strange to you or not, it's 9.8 meter per second, and it will decelerate the body, but it will decrease the quantity of movement, if you understand, till it will reach zero. And this is a continuum, 1.1, 1.2, 1.3, a continuum movement, and you need a law that will show this between 1 and 2 continuum, okay? So they made this is mathematics. But you will understand without mathematics. There is an energy of static energy correlated with mass and kinetic energy. Potential, that it is potential to give some movement. That's why it is potential. I have the potential to give with this fist a force to the wall, but I'm not going to. But I have the potential, if you understand. So the kinetic is when it moves. But when it moves, it is different, you understand. But if you hit, I told you, here, the energy decreases or increases. And the acceleration is different. The same acceleration, 9.8 meters per second squared, I've told you it's different of normal velocity. In this way, I throw this in the air, will consume the energy, and then with the same rate, 9.8 meter per second square, it will accelerate the body back. So somehow it is the same vector, perpendicular vector, you understand? So it does not the same thing. Anti-gravity already exists, but you are stupid if you don't understand, okay? The anti-gravity means in this way to consume the momentum of movement, and this way to accelerate, to charge the body with a force again, and that to be zero. That to be zero. The same principle are in the orbiting. You can apply the same law. You understand? And now I've told you that these laws were already given. They were made before Einstein. Energy equal mass. Between kinetic energy and mechanical movement. And then Maxwell made the law of electricity and magnetism. One of them says that if you move this current like this, you have a magnetic field that it might have the same direction and things like this, and will rotate like this, or you cannot have a movement from a pole to a pole. And this is electricity and magnetism. All of them are not connected. Galileo is not connected somehow, but only through the mind of the people that applies them in reality. Okay, so now I've told you that if Einstein made something, he correlated the energy, the electrical energy indeed, with mass. At any acceleration, now I've told you, if you take this like this and this, it is charging and discharging in a field. If you want electrical field, the field is not like you understand real. Just like I've told you earlier, if it will hit here, it will have another force and energy. They will still have some energy that will be converted in a momentum of impact, and all are correlated. Their properties of object, the force, the mass, the movement, electricity. I've told you this. It is energia from Greek, and it is not energy like this. I have energy, but you do not know how come. Like chemical or energia, it was a momentum of movement. It is important. Mechanical movement. In Romania we say lucru mecanic, mechanical work. Mechanical work. Some quantity of energy will give some quantity of mechanical work, like on a distance. And I've told you that the vectors are connected. This vector one, it is only space-time vector, 9.8 meter per second squared. But if you put in an equation, they will decrease in the energy, will reach mass. You understand? Like in a simple equivalency. You increase all the factors, the properties. The force increase, the energy increase, the mass. It is like a balance. It will increase the energy, decreases the mass, decreases the mass, increase the energy, and things like this. You understand that to balance the equations. You understand they are connected. Like you imagine many buttons. One is of mass. When you pull down some button will go like in this way, some button will go this way, so in many directions of energy, of force, of mass. Now, Einstein, I've told you that it is wrong belief that it is correlated energy of matter. The law already were given. Einstein asked himself, what if this rock will go through empty space at a normal speed? The principle of inertia that I mentioned said if I throw this rock through empty space, it will continue the rectilinear movement at infinity. It is saying strange to you or not? This is what says. But you can ask philosophically, why? Why the movement it is not consuming? Why? Why should not stop. Why? Why that this body should not stop? You throw it for 3,000 billion kilometers and it stops. Can you calculate the consumption of velocity? The consumption of velocity. And now you understand Einstein better from my previous video. They're already given the consumption of energy of movement through gravity, through G, 9.8 meter per second squared. You consume the movement until you reach zero, okay? So it will behave the same in the space. If you accelerate this rock, not constant speed, this is valuable, the principle of inertia. If you accelerate it through pure void space, that is the question of Einstein. What it will happen if you were going with the speed of light, okay? If you accelerate, not constant speed, not only meter per second square, you accelerate this. What will require? And from the Earth analogy, you must understand, I've told you, when you accelerate a car, you increase the consumption of energy, of gas. And the cars increase in velocity, okay? But in the pure space, you accelerate this body, where will go the energy? Where? It is the question. It will be absorbed by the empty space, void space, and the mass. Because this function should be true or not. The same like in Earth consumes with 9.8 meter per second square the energy of movement. In space it is consumed the energy of movement. And this is what Einstein, I believe, made. And now what is the rate of consumption in empty space? Of c squared. You see the similarity? The force is equal mass of acceleration. If you put the acceleration being 9.8 meter per second, this is the rate of consumption of mechanical movement on Earth. Any body, any rock of any dimensions has a rate of consumption of movement of 9.8 meter per second, but correlated with its mass. On Earth, you understand, I've explained to you in my previous video. But in empty space, maybe will matter the sun. No, okay, then you go and take the acceleration of the sun. And the laws are variable. Now you get the Einstein principle. The laws are variable anywhere in space. So if it does, like in the Earth, the acceleration consume movement. The acceleration must consume movement in space. If not, if you will trick like this. A constant speed inertial principle will move to infinity. And you'll trick it like this. You accelerate until a constant speed, and then you accelerate to another constant speed, and this way you will reach the speed of light. But the constant speed, it is not consuming, must be conserved. Inertial principle. So now you have the sun to consider the G of the sun. Like, don't be stupid. In Europe means to gravitate. You take like a force. The force is a force, F. But it is a changed thing when you consider acceleration. It's G, small g, meters per second square, and and it is rotate to mean to gravitate. I gravitate around the girl. It is correct to say like this even, okay, around it. So the gravity of the sun, it is not a force that it is perpendicular somehow. You understand, and you name it that it is attraction. It is not attraction. It's the rate of consuming of mechanical movement. The rate of consuming the mechanical movement. Understand? So if you accelerate from the sun, you take like the consumption of the G of the sun, Earth not being important anymore. If you are bound in the solar system somehow. But what it will happen if you are not in any vicinity of a star? What will consume your momentum? This is Einstein thought, if you understand right now. If you are not in the vicinity of any star, what will consume your momentum? You can trick to reach the speed of light. And this is what relativity means. One of the many implications. I will tell you, maybe, if you will watch my video, I'll explain to you what term of relativity. Okay, so Einstein said if we consume momentum with a g of acceleration, what will be in empty space the rate of consuming of acceleration? So to be equal, E equals m of c squared is like meter per second squared. This is the rate of consumption of momentum of movement. What is the rate of consumption of momentum of movement? C squared. It is the acceleration, you understand, in pure empty space. In pure empty space. What this does? It makes a conversion between energy and mass, between mass and energy. Somewhere must go the energy, and where? And this is the second problem that they have. Maxwell supposed that it is indeed like in this I've told you, maybe it's a field. It is indeed I believe that it is. It is an electrical field and it is charging, discharging. And you understand that the vector of gravity does something like this and another thing like this. And it is anti-gravity in the sense that in this way decreases, so property in this way increases another properties, the same vector. And it has the same direction, but does different things in different directions. Okay, so there is not, the gravity is anti-gravity, you understand? But I want to tell you that the universe is not accelerated, but you understand that I understand physics. So, if you want to accelerate, von Braun said this, there is no limit of acceleration in empty space. And these problems were known. So Einstein was wondering, what is the maximum speed then? You accelerate this body beyond the speed of light, it is even possible. What will happen to travel with the speed of light? You put like a rocket and you accelerate in 9.10 meters, 20, 30, 1,000, 3,000 kilometers per second. That is the speed of light in kilometer per second. I don't know in miles, 140. So 3,000 kilometers per second, that it is speed, it is not, you understand that the acceleration is different. The speed conserves the momentum, the acceleration does not. You understand? The speed conserves the momentum, the inertial principle. The acceleration does not, it consuming it. So the rate of the consumption is c squared, and it is identical F equal m of a. The a is the consuming factor, if you understand. You understand? Okay? So identically it is, and it is simple, and this is the law. You understand? So it is consuming the energy with the rate of c squared. So through equation you see, you put energy in the system, something must. So where the energy is giving, you can see in the system of solar system, maybe it is in the earth. The earth absorbs the energy, but in a void space, where does it go? In empty space, it will be logical. Empty space will absorb energy, will leave a trail of energy, of mass. It is the mass consumed, because the mass has an atomical bond. You cannot break the atomical bond of this rock so easily. So Einstein thought of these things, understand? So the energy must be consumed, and where it will go? Where it will go? Because if not, this object will become small. Not because you have some motor, because it must give some energy somewhere. You understand? But the atomical bond undertakes this. You must conserve the object. You have the object. So where the energy goes? And back in the system of acceleration, the energy increases the mass of the object, that to be conserved long. That the space, empty space, to not absorbing this. It's absorbed somehow because it is a rate of consumption. The c square rate of consumption. The c square rate of consumption. And I told you, it is valuable of any acceleration speed. Even 10 meters per second, 20 meters per second. And the graph will go like this, and when you approach the speed of light, will go to infinity. A property will go to infinity. So not to go above this speed of 3000 kilometers per second, because the mass increases on the graph at infinity, or energy, because they are bound. They are bound. F equals m or a, energy equals m of c. And this is an acceleration. You understand? So I've explained to you again the physics. So why do you have to suppose some black energy and dark energy and things like this? This is what the Maxwell, that he says that maybe this is a fluid, not a pure void, but in an electrical field, a low intensity electrical field, like light and ether was named. And it is absorbing this energy, because the void, how can be in a relation with an object? They are not stupid. But Einstein said we can to consider that there is empty space, void. But if you take the rate of consumption, the speed of light, and the energy will go in the object. You understand? You understand? So I explain to you again physics. So if a galaxy would accelerate, what will be the engine of acceleration? What will produce empty void space? Even if it is not accelerated, what will produce empty space? You can have a constant speed of galaxy of expansion if only the space is already infinite. In that space it is that you do not have a relation with a galactic, with a galaxy. But if you have a relation with galaxy, it must be somehow a continuum, and it will bound the law of the physics, and the galaxy will be heavier and heavier with acceleration. You do understand? And what will be the rate of consumption of entire galaxy? The rate of extinguishing a star. You understand? The energy of entire star, like you suppose. I'm telling you that the stars are small. So the expansion is false. But even the acceleration is more stupid and false. You understand? So it did not bend its space. You understand? If you consider the sun, you are stupid if you not take a circle of mathematics, because it will be useless, a rectilinear one, since the bodies have this trajectory in a field. But in the field, I tell you that I believe that it's electromagnetical, and it's charging, discharge. You understand? It's charging and discharging, if it is something. You understand? Okay. So gravity does not attract, maybe these things to remember. The stars could not be formed through gravity, because it is acceleration. And the galaxy could not be gravitational systems, because it means to rotate. You understand? You see the crooked galaxy, all the forms, possible forms, and we know only this kind of rotation. And another way to make zero, to make the same circle, but the galaxies are crooked, 90% of them. And in the rectilinear, you will not make any pattern, like somehow round pattern. You understand? So there is not, the galaxies are not gravitational systems. If they were, they should be to make zero perfectly round, like a solar system round, because it is not attraction. You understand? That the galaxies are stars, and they are alimentated from the clouds of it. You see? You will not know when the star will extinguish if it will consume energy like this. and you'll not know through light the mass. And the galaxy are cumulus like this, put in matter, and they extract electromagnetic energy from the clouds. The clouds, they are put in clouds of matter. We only see our galaxy that has 26 billion kilometers, and are stars small, like this, like a bobbin, like a motor, like in a cloud that produces thunder. The cloud has differential potential and it charges even wireless. A star could be like this, and the star produces a light, and you cannot know how it will be burning. Okay, so I infirmed the expansion of the universe, and you understand that we cannot see only our galaxy from a point, a lunet made by Galileo. Galileo will see through. This is physics, only to another point. So any telescope that you see from a point to another point. So you cannot see billion, trillion. Let's go and find out. The matter could organized in mysterious ways, not all spherical. There could be galaxies enclosed. Our galaxy is spherical, enclosed, and they could have stars. If you understand, like we have that neon gas light bulbs. You understand? Because nothing interdicts. Gravity does not move around the star. It is only in this galaxy, and this dark galaxy are stars, flowers of light, put in matter, extract energy. But we can go over this border of 26 billion kilometers. There is matter surrounding it, like an atmosphere of matter surrounding our galaxy. The Milky Way belt demonstrates this. And over 60% of Hubble pictures, the stars are put in clouds. If you understand, you look at them, you will see. And they are not gases. Laplace said this. Gases do not gather, if you understand what gravity is. So if you go at the next stars, there's matter, maybe even 26 billion kilometers. And you will see what is beyond our galaxy. I'm not crazy. I've told you physics, Einstein even. And nobody tells you this. They falsify even Einstein. You look at this Laura Premier Nobel Prize, and they falsify physics. They do not understand what, and I'm telling you physics. I'm not crazy. Let's see what is beyond our galaxy. The lunet, you cannot see it, only through a distance. You must understand. So this is what Einstein asked himself. What if you accelerate this body? There is no limit of acceleration. And he said, but it is. It is. Because the energy will increase the mass. And the limit, it is 3,000 kilometers. You cannot, another way, you understand. So goodbye, God bless. This is my third video. You watch them all if you want. On correlated with Brian Schmidt. The universe, we cannot see the universe. You must understand. It seems crazy to you or not, but you are crazy if you not understand that I know physics. Goodbye, God bless.